All right. So we've done this before. A problem like this. For the function f of x equals this, use the table to find when f is both concave up and decreasing. So what would be a good systematic way of doing this? What are the steps? So we need to figure out the critical points, and the critical points is when the first derivative is equal to 0, and then inflection points, no, the second derivative. So step one is to take the first derivative and find the critical points. So there's the first derivative, and we set it equal to 0. This particular one, factoring, I do the x method on this. We do the x method. Yeah, it goes like that. It goes first, the middle number to the bottom. 6 times 2 is 12. And get these two numbers, and that would be 6 and 2. It's funny because they'll probably think it's what kind of method is this? What do we do next for this particular method of factoring? Doesn't Chip do this method too? He does it, no? What must we do here? Does he do it like me? I don't think. He might do it a little different, no? What do we do here? This is particular my own personal method. I haven't seen it exactly like this. But what do we got to do next? Divide these two, 6 and 2, by that 6, yeah. We divide it by 6 and we divide it by 6. 6 divided by 6, you get 1. And then reduce 2 divide by 2, top and bottom. It's going to be 1/3. Okay, so now we want to find the solutions. We can solve and go x plus 1 equal to 0, so therefore x equals -1. And then we can rewrite this one as 3x plus 1 equal to 0 and then solve. But here, the solution is already here. They're just going to be opposite in sign here. So x equals -1 and x equals -1/3 are critical points. Yeah, I would think like I don't know. They wouldn't pay any attention to, I think, the way you factor. They would probably saying like, "What is this?" Well, they did get the answers, but this is not a very popular way. I don't see it a lot of factoring. In any case, let's go on to, we've got these critical points. So now we got to find the inflection points. So we take the second derivative, f double prime of x, and we set it equal to 0. And then we can solve this, -8 divided by 12, and whatever that turns out to be, -2/3 reduced completely. What else? So we have to like sometimes make sure that it is an inflection point. And how can we fully verify it is an inflection point? What needs to happen that it is an inflection point? Needs to change signs. And if you can just like quickly, I guess, do that part in your head and say what are we gonna do? Test what at x equal -2/3. You have to change signs on -2/3. So you can test like a number on the left of -2/3. What's a number -2? What is that? -2 or something? That's for sure, no? -2, and then that's going to be negative. Yeah. And if you test like 1 or something, or 0, yeah, 1, that's positive. So it changes signs, no? So it does change sign. Yeah. We made some changes here. You want to sit on there, or you can sit right there, right here, this one. So yeah, you just maybe I don't think they would do any of this for you to actually test it if it is concave up. Maybe they would. I don't know. But just to be on the safe side, you want to test that it does change signs on the AP test. No. Moving on. All right. So it changed signs on the inflection points, and then these are the critical points. Well, we are going to test it anyways here when we make a table, because we are going to make a table. So why don't we get these 3 points, no? These 3 points, and set them up right here on the table. All right, let's go like this. I'm trying to give you kind of like a systematic way of how to do this one like this. So put those points. -1 is the leftmost, -2/3, and -1/3, knowing that this is a critical point, that is an inflection point, and that's a critical point. So f prime of x at -1, the slope is 0. No, this is 0. That's not dealing, -2/3 is not dealing with f prime of x, it's with the f double prime of x. So -1/3 is where the slope is 0. No, so here this one's 0. And the signs to the left and to the right of these, I guess we should be testing that. I guess also here. So going back over here, and we're gonna test left in the middle and all that. We already did this one for f double prime. No, we did this one. It did change signs from negative to positive. Yeah, we did that one right there already. Let's test then f prime of x. So we're gonna test this one, and we could test one number. What number can we test here? -3 or something? -3. It's gonna say, what is -3 gonna do? -3. That's gonna be positive 954. That's gonna be positive, is it or not? Yes. It's quickly, this is way bigger than all this, and it's positive, so it's gonna be positive. So this one's positive. This is positive. And then in between -1 and -1/3, we can go ahead and test -2/3. No, we can test this -2/3 for this in the middle. Quick, I guess, -2/3. That's going to be what? 4/9. So it's going to be 4/9. Times it by 6. What did I write down? This -2/3. -2/3. That's going to be what? -24. No, negative what? 16 over 3 plus 2. Oh man, this is going to be 6 going to 9. Divided by, divide top and bottom by. Oh. Let's go just multiply 24 over 9. 24 over 9 minus 16 over 3. I just want to know if it's positive or negative, that's all. 9, that's going to be what? Plus what? 18 over 9. 18 over 9. Common denominator. 18 over 9 is 2. Times this by 3. 3 times this by 3. Okay, now we can figure it out. Oy. What's 24 plus 18? 24 plus 18 is 42. Is 42. And then this is what? Negative minus 48? 16? 48? It's going to be negative, huh? So you just got to know the sign. What is the sign? It's so close. It was close. It did change. And test the other one over here, and it's going to be positive. Okay, so okay, now what are we gonna do? Now that we have this, this helps you a lot in seeing it. So let's make a table kind of thing here. How do we get to kind of like cut it into pieces here? And let's see. Look, it's negative. So what do we want? We want concave. What is it? Concave up and decreasing. So where is it concave up? Where is it concave up? What do we look for in concave up?
Second derivative.
So we're looking at this right here, the bottom one. And concave up means what?
Second derivative is 1.
So we're looking at this, no? We're looking at this. And okay. And then what else are we looking? Decreasing. What are we looking at decreasing? That F is decreasing. See another one, no? F is decreasing. Where's F decreasing?
The first derivative.
Is what?
Negative.
When the first derivative is negative. So it's here. And where they overlap would be it. So where they overlap, it would be what we want. And so this is where they overlap here. There it is, no? So negative 2/3 to negative 1/3, negative 2/3. So how do we answer now this? So let me then get rid of everything I got here. Okay, so we did all that. Now, and we identified that this is our interval. So here's a sentence frame again for hopefully that they would accept this and say it's fine. F of x is what and what on the interval because. See, we always have to have a reason why this may. So f of x is both concave up and decreasing. On the interval, what?
Negative 2/3.
Okay, so are we going to use brackets or parentheses? Parentheses. So let's go with negative 2/3 to negative 1/3. Because what? Because why? Well, why is f of x concave up? Let's answer this first. Why is it concave up?
F double prime of x is greater than 0.
Okay, f double prime of x is greater than 0, and it's f is decreasing. Why? F prime of x is less than 0. There. I mean, if they don't give you all these points, then I'm done with this. That's fine with me. Let's go with the next problem, number 2. Not that. What the heck did I just do? Let me go to that's my work. You see how there's presentations, and then there's where I do my final presentation. I was working on that. Let's see, is this number 4? No, it's gonna be number 5. All right, go ahead and do problem number 2 again. Work on that. Give you some time. All right. Man, what am I gonna do? Am I gonna stop? See, this doesn't have a pause here. I'm trying to pause it so I can keep going. Stop. Man, I'm gonna stop it already.